right here. Wow, I don't see a sign. I mean, you can see what it is. That says no parking anytime. Yeah, but there's no like sign showing you bike path, right? And then once you get in here, it tells you this. It's just telling you the rules of the path. Well, let's go ahead and practice carving again. I feel like it's wrong to say that because I don't feel like this qualifies as carving. I don't feel like what I'm doing qualifies as carving. But I'll call it that. This doesn't have a sign either. This almost looks like a driveway, someone's driveway, right? In the beginning. I don't know how people find these paths. Like how many, I do wonder how many people in the community are aware there's a bike path here. I wonder that. And then in the entire city. I wonder how many people in this city, in each city there's a bike path. I wonder how many people in that city know they have a bike path in that city. However many bike paths they have. Whether they use bikes or not, I'm just curious how many people know that there is one. Because the bike path really is an alternative transportation path. It's a zero fuel path. I mean, the signs say that you can't use fuel-powered vehicles, right? No motor vehicles, right? They don't want motor things with using gas on these paths. So these really are the alternative transportation paths. That's what these are. So these paths are the future of transportation. And look at them. There's no sign where the path is. There's no signs telling you how to get to the path, right? There's no lights. This one has no lights. It's totally black, dark at nighttime. And then the other paths that have lights, the lights don't work, a lot of them. We saw that in earlier this evening. And then the paths start maintained. You see these bumps here? Look at this one. That's a real big one. That's enough to crash right there. And people do crash. People have crashed there. Their hand slips off the steering and they go flying off their bike. That bump is like 5 or 6 inches tall, and it's almost straight up in the air. It's like hitting a little brick wall right there, like a little brick in the road, just slamming into it. And when I was on the V10F coming up here, hitting those, I would go up in the air because that didn't have suspension. And I was surprised I didn't crash. I was very lucky. I just stayed on it. I mean, I just stayed with it, is what I'm trying to say. Which is what they teach you in electric unicycles. Is don't just jump off of it. Try to stay with it. And try to ride it out, right? And try to straighten it out. Try to get it straight again. Keep it straight. Let's see. Okay, so traffic is increasing because the morning is progressing here. So traffic, it'll continue to get more and more busy. As the morning progresses. So going back to Don Smith's Magnetic Resonance Energy Crafting Systematic Index book and what he's sharing in there, let me try to share with you what I think he's saying, okay? My understanding of what he's sharing. What he's saying is, and this is backed up by MIT alumni as well. There's actually patents on what I'm going to share with you right now on some of these ideas. I'm not sure how you get a patent on these things, but I'm just going to share with you what I think he's saying. He's saying that electrons move in an infinity symbol, and they're in pairs, okay? So imagine electrons are made by the sun. This is what he's saying. Now maybe this is his theory, but here's the thing. What this man did worked, okay? Now, Don Smith sold his inventions in business, and he also was somehow allowed himself to be convinced that his technology was going to be everywhere in the world. That's my understanding. He thought he had success. He thought he changed the world. He thought he saved the world. But in actuality, his technologies were not available everywhere, and they were used for the maglev trains. For some of those, they were used for many businesses, right? But I'm going to use the word private industry because it wasn't like you and I could just go buy his system. He did sell a system to someone, and this is a really sad story. He sold a system to a private party. I forgot how much power the system was. It might have been like a 4,500 watt or 5,000 watt system. And I guess the person said they just want to use the system, you know, they're so grateful that they'd love to buy one. You know what they did? They took it apart. Tried to figure out how it worked. And it never worked again. I mean, you can't just like start unwinding coils, taking stuff apart, and expect things to be balanced. Like, that doesn't make any sense. I'm trying to think of how to compare that to something. Imagine a piano, right? Imagine a piano is tuned perfectly, right? And a master pianist is going to play at a concert, right, with this piano. And but someone says, I'm going to take this piano apart piece by piece, and I'm going to find out why it sounds so good. They put the piano back together. The master pianist plays on the piano, but it sounds terrible. What do you think happened? It's not tuned, right? So you can't just take things apart and think you're going to reverse engineer something unless you really understand what it is. Now, you can be an electrical engineer and still not know what you're looking at, because like Don Smith said, this is like ham radio area, and that doesn't mean you're going to understand it. It just means you'll understand it better than probably better than I'm guessing than an electrical engineer, because an electrical engineer is not going to be familiar with this approach, you know, to energy extraction from electron pairs. Okay, so we're talking about energy extraction from electron pairs, and when Richard Feynman said there's enough energy in a cubic centimeter. I really hope you can hear my voice because I know the wind's blowing. There's enough energy in a cubic centimeter, which is the size of a sugar cube, to boil all the Earth's oceans instantaneously, or to power the whole planet indefinitely without end. Meaning meet all the energy needs of all the electricity energy needs of the planet, right? That's transportation, housing, heating, cooling, everything, all the energy needs in a cubic centimeter. Now to me what he's talking about is he's talking about the energy available in electron pairs. Okay, that's what I see when he made that quote. Okay, now Richard Feynman is a Nobel Prize winner, and he taught at Caltech, Pasadena, California Technical Institute in Pasadena. I think that's the proper way to say the title. Please look it up yourself. Caltech, right? Caltech, Pasadena, connected to NASA, connected to JPL, meaning they work together, if I understand correctly. And this man knew what he was talking about. He also said that history is fundamentally irrelevant. Now he's speaking, to me, he's speaking in the context of science and scientific discovery and the theories of physics, which many people will call quasi physics, right? History is fundamentally irrelevant. What do you think? What do you think about that? Imagine that a person spends their whole life teaching, science around the world, and someone says it's all irrelevant. Well, my understanding of what he's saying is that what we know does not define what we can do. And we cannot use the past to determine what's possible in the future. I mean, that may work sometimes, but it's not absolute. The past doesn't entirely define everything we can do. That's my interpretation of that. Now that can upset people, or people can say that's the stupidest thing I ever heard. That's fine. I'm talking about infinite possibility. We're made up of infinite possibility. We're made up of the universe. The universe is made up of us. It's a symbiotic relationship, okay? I'm talking about thinking outside the box. Okay? Now some people say, oh, the instructions to get out of the box are on the outside of the box. So you're in the box and the instructions to get out are on the outside. Okay, to me, thinking outside the box is recognizing, respecting, and acknowledging, appreciating, and acting on the statements of Richard Feynman when he says these things, the quotes he said. And Einstein too. Imagination is more important than knowledge. When Einstein said imagination is more important than knowledge, I think that Einstein and Richard Feynman are speaking the same language, and they're on the same page. To me. We'll continue right now when I cross the street. I'm focusing on what the traffic's doing. There we go. Einstein said, imagination is more important than knowledge. I see a relationship between that statement and Richard Feynman saying history is fundamentally irrelevant as it relates to science, right? Because we're talking about a scientist here, a philosopher. To me, Richard Feynman and Einstein were both philosophers, poets, writers, scientists. So,